So I'm Michael Zargham. I'm the founder and CEO at Block Science. I'm going to be giving a short presentation about prefigurative self-infrastructuring for knowledge networks. I promise I will explain what that means. And then we're going to be doing a demo with Ryan Reed, also from the Block Science team. First thing, these are some big words. Prefigurative or prefiguration is basically when we change the way the world works by basically acting like it's already the way we want it to be. Sounds pretty straightforward. It's actually pretty hard. It's pretty central to the way that we create institutional and structural change, though. Cool thing about today is that we have technological infrastructures that we can build that themselves actually entrench or encode the patterns that we want to follow. And so today we're going to look a little bit about how we can do that with knowledge organization, decentralized science, and just generally changing the way these institutional patterns work by building and using tools. This is the last really wordy slide, so please bear with me. I'm just trying to get the basic definitions in. I'm going to talk a lot about knowledge organization. The thing is that organization here basically means how things are interrelated. So we're talking about how content is captured, organized, preserved, used, the procedures that we put in place to integrate content, basically the underlying kind of practices, tools, patterns that we use to organize information and actually use it to drive outcomes. And in particular, I'm interested in ways of doing this that embrace evolutionary change. So getting out of these kinds of static calcified patterns, which are basically so busy convincing themselves that they're right, that they're not actually checking if they're right anymore or even connected to the world at all, potentially. And that doesn't really sit well with me. So in my opinion, and not just in my opinion, organization is a very relational concept. So not organizations, but how things are related to each other. And so there's a kind of canonical cybernetician, Ross Ashby, who talks about organization in a variety of contexts. But one of the most important aspects of this is that sometimes how things are organized is more important than what those things are, which can be a little bit confusing for people who are used to building things and really optimizing their components and making the part awesome. But actually, a lot of the outcomes that we want are going to come more from how things are interrelated with each other than how phenomenal or perfect or mature the individual technical component is. And so the goal here is to step up a level and actually ask questions about how we're choosing to organize knowledge and how that affects what knowledge is produced and how that knowledge gets used. So you guys have all encountered this problem, things that are truthy versus things that are true. And this is a little bit of a kind of tongue-in-cheek statement, but the way our current kind of knowledge consuming and producing infrastructures work, practices in society, most things that by the time they get popular or become well-known, they've been kind of reduced to these low-dimensional marketing blurbs or memes. There's nothing wrong with memes. In fact, some really potent memes can carry a lot of very true information, but the scientific process produces new information. And I think we'll find we need to create ways of pushing through when things that might otherwise be seen as, oh, that doesn't make sense or doesn't feel intuitive, needs to bubble up. So in practice, what we're seeing is a need to create adoption and sort of institutional legitimization of work that's coming through these alternative channels, whether it's DeSci or really just researchers in non-traditional environments or artifacts that aren't traditional PDFs published on canonical journals. And that information is still important. We're still learning, discovering, producing artifacts. We need to find ways to get them up into this upper right-hand corner, this sort of kind of legitimate scientific theories, and get this ball rolling again, because it's kind of calcified in my opinion. And not because people aren't doing work, but because the sense-making apparatuses, the knowledge organization infrastructures just don't line up with the needs of science. So what is DeSci? Well, it's identifying what are promising directions to research, creating incentives, enabling coordination among researchers to achieve outcomes, making research artifacts legible and citable, organizing and curating research, and much more. But ultimately, a bunch of interconnected processes by different actors in different roles and contexts doing complementary activities to produce new ideas and ultimately sift through them and legitimize them. So what are we doing about it? And I mean that both myself and this community and various organizations that I'm involved in. This is sort of a collage I made this morning of things that I've hacked on at various points, starting from my literal ancient history. That's my academic lineage. I had to go look it up, but I'm down in the bottom corner somewhere, and there's a mathematical, like mathematician's genealogy project that actually curates a data set of the genealogies of people with advanced degrees in mathematics. I'm a control systems engineer. I worked on some very early crypto cross platform content distribution platform stuff. I've messed around quite a bit with the IPFS and like kind of protocol lab stack of tools. There's actually a zine that I published with a friend of mine called Navigating Information Infrastructure, which is published in IPFS. There's some old tweets, kind of going back to the previous conversation. I'm actually having a conversation in that thread with Joel from Ceramic about knowledge infrastructure and attribution and attestations, and some old sketchy diagrams. There's a half-written paper on attribution networks that I've been talking about with Chris, how it sort of died by its own topic. Like it's about the issues with credit attributions and incentive for science for people who aren't in academic roles. And it's like 3/4 written with my friend who was at the time a PhD student at Columbia. And like he finished his PhD and I got busy with my company and it's just sitting there on Overleaf and it's like, 5-year-old now, half-written state. There's work on SourceCred, which is a fun project for creating attribution networks for code commits and discussions and forums for building an open source software product. Recently gave a talk about knowledge organization infrastructure and AI with Orion at the AI track. Not going to dive as deep into that today, though we will show a demo of part of it. Also just looking at things like the reference identifiers and kind of what is objecthood in digital settings, rolling all the way up to the thing I have in the upper right, which is with Chris's help, I pushed some content to the Codex network, which is one of the DeSci Labs projects. And I thought it was pretty sweet. And I thought it merited the now point on this chart. But today I'm going to talk a little bit about basically what I call the politics of protocols. And that basically means that when we rearrange the way that we organize ourselves, we also rearrange the kind of activities that are undertaken. So this is the kind of, I guess, top line statement that I like: harmony without loss of variety, variety without loss of harmony. Basically, this means that we want practical pluralism. We want to be able to do lots of different stuff. We don't want it to have to be exactly aligned. We want it to be aligned enough that it kind of coheres, that you can refer to things, that you can say, hey, there's some concepts in common here. There's some dependency. This informed me. This motivated me. I totally disagree with this, but it made me go and prove that person wrong. And you want to be able to do that within a framework where you can keep track of that, legibly review it, understand it, not just from the topological graph, like, hey, there's an arrow back to the paper that I really wanted to prove wrong, but actually some additional semantic meaning of, hey, I was really motivated to prove this paper wrong. You may or may not agree whether I succeeded, but that fact about the relationship is pretty important. So in this world, I no longer have a clicker. Okay, so this is there's actually that QR code is a link to a short blog article. That blog article is a kind of project description, and the research question that project description is working on is: how can developers ensure user instance open source software is customizable enough on one hand, but also sufficiently standardized on another, so that you're getting this like ease of use, easiness to maintain, but also configurational freedom and kind of interoperability across different instantiations. And this is not trivial, right? This is a really sharp problem of trying to find exactly which things should be flexible and exactly which things should be rigid. And I tie this back in my thinking to this is a awful paraphrase, but there's another cybernetician, Stafford Beer, who would always say that systems are neither decentralized or centralized. They're both at once in different dimensions. And the challenge of protocolization is actually figuring out where those lines should be. Which things should be decentralized? Which things should be centralized? And how does that affect what can and will be done within those ecosystems? So this is actually related to work from one of my colleagues, Kelsey Nabin. She wrote about self-infrastructuring and Web3 during her PhD thesis. She recently graduated from RMIT in Australia. And so I want to give a big shout out to her for kind of spending several years really diving into these concepts and developing some of these ideas so that we could go ahead and actually try to implement them. And while at the same time thinking about them deeply and not being kind of naive about what we implement. So within our team, we have a kind of mixed method strategy. We do software engineering, engineering design, kind of systems engineering stuff, and we also apply ethnographic methods. Believe it or not, it's pretty simple. It's do the thing, think about it. Like talk to other people about it, talk to your users, but also like understand the consequences of what you're doing and maybe avoid some of the short-term pitfalls where people think that they want one thing, or in the short term, one thing is appealing, but actually has long-term undesirable systemic consequences. And so we're not just reflecting on the thing in the traditional user feedback way, we're reflecting on it at kind of multiple orders, including doing some relatively detailed, longer ongoing ethnographic work and also doing some kind of system science, kind of, okay, what are the consequences of this? But at the end of the day, we don't want to get caught up in that, because if we're not also doing the thing, then we aren't actually having contact with reality in order to inform those judgments. So this ability to move back and forth, or even in some sense do both at the same time and have them depend on each other, even reference or cite each other, is quite important. So quick note on what does reflect on it look like. Here's another paper from Kelsey. She's actually continuously interviewing and following the various activities associated with building some of our internal AI and knowledge management system stuff and publishing about it and looking at it in the context of AI accountability literature. On the other hand, this is the rough sketch of the software that we demoed in the AI track. It's the outline of the software design that I put together and that Orion implemented. And we built that software, right? We demoed it, it works, we're iterating on it. And so these two things are actually happening at the same time. Whether that's happening at the same time within the same org, within the same research community, or within research at large, doesn't necessarily matter, but they all need to be happening and they have to be interconnected. So then another way to think about this is that we have divergence and convergence. This can happen in terms of researching, exploring, and kind of building and exploiting, but it can also happen in the kind of sense making or canonizing, taking things, sifting through them, reproducing them, demonstrating some validity, or defining the context in which something is valid, identifying the same concept emerging in a different area. That gives us convergence. And so we need divergent and convergent processes to be happening at the same time. And we need them to cohere, not necessarily agree, just cohere. And so this is a recurring theme for me, this idea of coherence, which is not consensus. Coherence doesn't require things to agree. It only requires them to be sort of mutually referable. We can say things about how they're related to each other, but they definitely do not have to agree. So then kind of coming back to this looping metaphor, which not surprising as I'm a control systems engineer, we're looking at the way the knowledge organization infrastructure serves as a kind of sensor apparatus, a big distributed sensor apparatus for science, and that the funding and incentive mechanisms are basically actuators. And if this is a big sort of open ecosystem with all of this latent potential that can be unlocked, if we just organize our resources a little bit better, we don't want to revert back to a new centralized institution. We want an actually distributed control system made up of sensors at the level of every individual researcher and research organization or community kind of working together to create this coherence. And we want to enable a set of funding apparatuses that actually can make sense of the data produced by those sensors and make decisions that actually materially advance science and produce useful technologies. So I'm going to kind of wrap up by looking at this as a stack and kind of giving shout outs to some of the other folks around here at DeSci. The very bottom of this is going to come back to some Web3 tooling, things like Ethereum that provide decentralized ledgers, or even just clocks, shared clocks, so that you can see when things happen and get some basic order of events can be very important. In my sort of view of the current stack that's emerging, we've got something like Ceramics anchoring service providing a clock that it sits behind tooling like the data streams that are coming from ComposeDB, which uses the ceramic network to publish basically schemas and fill them in and get data over time, not necessarily trying to maintain a global state, though the blockchain layer is only really good for event logs and things that really need to be global. And as you keep moving up this, you get to things like DeSci Labs Codex, which is a little bit more specific. So each level up here, we're getting more specificity. And so when you get into organizations, heterogeneous incremental publications and attestations, we're getting more scientific specific data, and that kind of data grid created by the bottom three thick bands actually is the kind of infrastructure that enables a massive plurality of organizations and individuals, activities between individuals and organizations, and activities between organizations. And so to kind of paint some color into that, I can throw in some people and orgs. We've got me, Orion, and Kelsey, who I mentioned earlier. We work at Block Science and are actually all involved in MetaGov, which is the white box with the slash in the middle. That's a nonprofit working on digital governance. But then there's a bunch of other orgs within our kind of universe. And what I like about this is that we can have traditional and Web3 type institutions, and for all that it matters, kind of patterns of labs and or institutions that don't even exist yet, because this kind of grid doesn't really care what shape you are. And in the long run, what it should really care about is whether you're producing valuable research and whether other entities within this graph think that you're producing valuable research, and whether that results in this kind of convergence, divergence process that's actually productive, this application and reflect process that's actually productive, this document and track what has been done, including references, attestations, and semantic relations, plus incentives that actually push for doing things that are productive. All of that becomes possible in a much more realistic way, much more adaptive way in a networked ontology instead of in a sort of top-down hierarchical ontology that we have today. So that wraps up my lecture, but Orion's going to show you some cool stuff. So we're going to switch over to his computer, and yeah, we're going to see some of the fun stuff. Questions, yeah. What was that? Oh, yeah. So when I say user instance, I mean that the user community is capable of provisioning their own. So in our case, if you build an open source software, the code is open source, but that doesn't necessarily make it easy or useful to create an instantiation. So like a service. I'll use SourceCred as an example because that's, I think, a little easier to go find than some of the new stuff that we've been talking about. But like SourceCred, the org, had a code base called SourceCred and an instance of that code running as a service in the cloud that served the community that built SourceCred. Now, this is very confusing because all three of them were called SourceCred. In fact, I think this is one of the challenges that that community had because they didn't clearly distinguish between their code base that they were building, their community of people who were involved in the activities associated with building the code base, some of which were software development, but others were product discussions, other were user feedback, some was sort of marketing, some was going out and trying to get funding or finding users in new orgs. All that organizational work was also part of the org SourceCred, but specifically I'm talking about user instance that like SourceCred's code base, you could follow a set of deploy instructions, spin up your own instance, and you could configure it for yourself, and then that org could use it. Now, if you really want to do, you could do it for a single person. In my experience, anything that requires non-trivial DevOps is probably best understood as an organizational level affordance, even if it's strictly possible for people to build their own kind of knowledge organization infrastructure. But yeah, you're right. I didn't define that, and I'm thinking specifically about things that when I go get it, I'm not just saying, oh, it's an open source software and someone will host it for me, but as long as I have the technical skills, it should be as easy as possible for me to spin up my own, or for me and my friends to spin up my own. I can take another question if you like while we get the demo going. Yeah.
Great talk. How much do you think we can leverage existing infrastructure and resources within academia? And how much do you think we need to rebuild new schemas or rebuild new data sets? And in your experience, how difficult is access if you don't have institutional affiliation?
ceasing to have a prestigious institutional affiliation was a little bit of a shock. So like I was at Dartmouth for 5 years and Penn for 5 years. So like I just sort of assumed that the world worked in a way that like, oh, you just have access to all these things. And so when I actually left that world, I was thoroughly like, oh my gosh, wait, I have to do what? Like, what do you mean I can't have that? It costs what? And so I will say this, I think it is possible to vampire attack the institutional infrastructure. But I also think we have to be careful about how we do it, because if it's just a purely antagonistic thing, then we're not going to get buy-in from institutions and get them to help. And so in some ways, I think that a lot of the knowledge and a lot of the knowledge infrastructure is reusable, certainly the ontologies, but the ways in which we create and consume records need to change. And I like the notion of open state data networks, because when you make that change, then I think you could imagine knowledge starting to effectively bleed out. Like it's there, it's piled up. I don't know that it wants to be stuck in there. I mean, I've literally had to quote unquote pirate my own papers because I couldn't find them in my own computer. And like, that's terrible. I mean, I guess I don't even know if that's technically pirating. I had to go find a copy of something that I clearly had the right to read to check my own work, because the default mechanism had a paywall on it that I no longer have access to, which is infuriating, to be totally honest.
I mean, I like the question, and actually what we can see that in detail, that existing infrastructure, but new infrastructure gets leveraged. So how can we really make an Uber out of the facilities, to make them usable for the community?
So the way that I think about this is that as much as some legacy institutions don't perform very well at their sort of stated or purpose function, I think a lot of them still, at least at some level, know why they exist. They have some telos. And so part of what I think could happen, and I don't know that this is true, is that if we make it easier to achieve their purpose, at some point, those systems may start steering into that. Now, I think they have a lot of momentum, and turning them is really hard. And so I don't expect that to be a snap change. But like, if the purpose for your institution is to produce and curate and distribute knowledge, then at some point, if there's a way to do that more easily, you'd expect it to start to get picked up. And I know that there will always be some organizations that push back on that, or are so conservative as to say like, oh, we're not going to do it the new way. But you only need a few to really start doing it. If it's enough better, the ones that don't are going to fall behind. But it's almost a generational shift thing. I think that's part of the challenge. We want it to happen really fast. We can build the infrastructure that allows it to change and still have it change a lot slower than we'd like. But it's still required. Like, it won't happen if we don't build the thing.
What do you think about having kind of an over-complete corpus of schemas that perhaps that aren't high quality, right? So, where some schemas, because they might serve some utility quickly up front, kind of take over, and then you get this consolidation or maybe less than ideal ontology.
So here's the thing. I don't know that I believe in an ideal ontology. I mean, I certainly believe some ontologies are better than others in the sense that they're more useful for specific things. But my mental model of ontologies is pretty close to local linear approximation in control theory. You've got a world, it's big and complex and really gnarly and messy, and which, if you're dealing with at least kind of certain kinds of nonlinear systems, you just grab a local linear approximation and solve the problem. But if you move even a little bit, the right local linear approximation is different. So you got to be really careful with those kinds of models. There are others, like nonlinear systems models, they're going to fit over a much wider range, and then successively more and more complex models that might be more germane to reality, but they might actually not be particularly well fit to a use case. So if you take ontologies as just models, you think of them as local approximations of the relations between concepts, then rather than saying an ontology is good or bad, you just say, is it useful for the context in which it's being used? And then you get this kind of manifold-like thing, which is a giant collection of loosely related ontologies for which you can kind of move through and across it. And again, that's a kind of a mental model, not necessarily a formal or rigorous provable thing, but that intuition is actually coincident with the intuition of like the latent space that LLMs are drawing out, which is like, clearly it's not the actual true ontology of the world, but it's pretty good at reverse engineering a kind of topological map of the relationships between concepts. And if anything, the problems we're facing come from the fact that we're over-indexing on the data and maybe not always doing as much work to actually write into it relations that reflect our more, let's say, creative or oversight, like actually this means that. Or in my opinion, actually, this means that, which might be actually a more correct way to express that. So yeah, I think in my worldview, these ontologies can coexist, and many of them might be pruned because they're not useful for anything, but many of them might be just different and materially useful for different things and relatable.
Say this, but is it naive to think that these institutions' main function is to create knowledge versus the incentives that they have, which are really more aligned with creating remarkable IP or taking in alumni?
That's a good question. I'm going to go back to Stafford Beer for a second, and he had this great other quote, which is, the purpose of a system is what it does, because there's no point in basically arguing that its purpose is something else, which is closer to what you're saying, is that the revealed purpose or the like realized purpose of these systems is clearly not to produce knowledge. But
that's
yeah.
right. It's aligned with what their action and help you do a better job of that. Then maybe we got the system.
Maybe. But I actually, and I'm going to give Chris credit for this, think that there are a whole lot more Homo scientificuses than there are Homo economicuses out there. We just don't necessarily have the institutional apparatuses that we need to reveal those preferences. And so I'm not going to deny the existence of actors and institutions that are caught up in that feedback loop. But I think sometimes the feedback loop is stuck as much because of the existing pattern as the lack of awareness or the lack of ability to implement an alternative pattern, which is not as naive as saying it's just going to work. It isn't a like if you build it, they will come situation. It's a you have to build it, then you can do the other work to try to make the change. Like it's necessary but not sufficient is basically what I'm saying. The problems you're surfacing are still very real. And I just think from this sensor actuator perspective, if we don't have the sensors, then making a better funding actuators just can't work. Anyway, do you want a demo?
Yeah, I can do a demo.
Cool.
This is working. I'll do this real quick. So I'm actually just going to demo one small part of this, but I just wanted to point to the fact that with this infrastructure, we have a bunch of different interfaces. So we can talk to this LLM-backed system in Slack. We can have this kind of internal search-based interface within our knowledge base. This is basically another version of the same thing that lets us do some tagging and curation work. But the fun and silly one that I want to show you all here is we have this multiplayer canvas-based interface, right? So this is multiplayer, and you can connect to a bunch of peers over like WebSockets with CRDTs, so you can see their cursors moving around. Really nice environment for collaboration. But just like with the other interfaces, we can connect this up. So in this case, what we've done is we've just bound a particular visual state to like computational processes. And we're basically saying here that if you're a green shape, you're a knowledge-based query. And so I just arrange these a little bit. We can, woohoo. Okay, there we go. So, and here we're doing some LLM stuff. It really doesn't have to be LLMs. It's kind of arbitrary, but just as a kind of demonstration of that, we can take that query and then we can kind of stream it and execute it as a DAG here. Well, you can have cycles as well if you want to go crazy. But the nice thing about this model, other than it kind of being quite fun to look at, is that you get this kind of natural, what I've been calling like a bring your own access model, right? Where if you connect to someone as a peer, and you're just kind of using this interface to do kind of coordination and organizational work, the actual kind of knowledge or resources that you have access to is basically like the sum of everyone's individual access, right? So if you're two people from two different orgs with your own local knowledge bases, and you each have individual permission to access that stuff, then you become the kind of gatekeeper to anyone else that you're connected to. So I could, for example, make a query. I could, if Z was in a different org, we could both be in this environment. I can kind of request that query, but he's the one that ultimately has to approve it, right? So we still have this kind of nice human mediated barrier so we don't accidentally violate any contracts and stuff like that. I think because I think we're running quite over, so I think I'll probably leave it there. But definitely do feel free to ask me about any system design or implementation questions.
Just a caveat that in my last diagram where I showed the layers, we're basically demoing what we have at the organizational infrastructure level with affordances for interorganizational and research to organization level. And although we don't have it yet, we've been talking with some of the other folks here about getting some of this knowledge organization infrastructure plugged into and able to read and write from some of the broader data grids, like the stuff was on the bottom of my last slide. I really like the multiplayer, like just being able to log in from separate computers and connect and then have one person who's connected to one organizational knowledge base, another person who's connected to another organizational knowledge base to be able to make joint workflows where we still respect the individual's authorities within their org. So you can't, like I can't use his and he can't use mine, but we can still wire something up together where we each use our own individual data and computational process rights to generate a collaborative workflow, which again, for us, we see as kind of the future of computationally aided inter-organizational collaboration.
As one example of that, something that we experimented with is basically you take a DAG like this and you basically delegate different nodes to different clients, right? So I could say, for example, that, I'm going to take responsibility for this red one and that Z on his machine is going to take these blue ones. And I'm basically going to do the computation in the red box. It's going to via a client side peer connection to him. It's going to pass it over. He'll do it. And then it will return to the rest of your peers. And there's a lot of really nice kind of composability you get for free there.
It depends on what the stuff is that you're dealing with. So what we've been focusing on is use cases where the materials are largely published under open source or Creative Commons licenses, so they're not an issue. I would strongly recommend, and I actually actively am using like kind of internal business processes to select what's even accessible to these systems. So we have kind of at least two layers, two off the top of my head that we're using. One is just there are things that are simply not accessible to this. You should not connect things to this that you definitely don't want to come out. There's also usually three layers. There's also individual data access rights. So these systems still points back to documents where they are. So if, for example, I don't have access to the document, even if I know about it, then I can't access it. So there's the kind of aware of it in the sense that the system's aware of it at all, because we keep things that are actually sensitive out of the database. Then there's the knows about the thing, but you don't have access to it limitation. Then since we're using LLM systems here, we have a kind of almost like constitutional layer where you can say, although not perfectly, you can provide some restrictions on what kinds of things it will reveal. If you ask certain questions, it'll just refuse to answer them. Strictly speaking, though, it's a layered solution. You're going to have a bunch of different security layers, and they're going to depend on the sensitivity of the material. And actually, that's one of the things that Kelsey wrote about in that LLM accountability piece. And there's a new version of that that got accepted to a journal, which of course you can't see because it got accepted to a journal. Maybe it'll be out in open access at some point. I don't know, but I just know that they accepted it and it's still currently not available. So you could read the old one. Go figure. But yeah, you're totally right. That's actually, I mean, the thing about the technical tools, especially as someone who runs a company, is the technical tools are awesome and the sort of legal and contractual stuff is the headache. And so but you got to work through it. And I generally describe this as the complementary role of practices and tools. So you need to build the tools to enable the practices, but then the practices are going to have to handle all sorts of other issues that the tools can't and probably shouldn't do for you. Thanks for listening.
Sweet.